This is called section 7S2, and this is called the rational rational exponents. Exponent. And does anyone remember what a rational number is? Rational number. We talked about this early in this semester. Yes?
Any number that can be expressed as a fraction.
Oh, yeah, exactly. So rational numbers are numbers that can be expressed as a fraction. So like integers are rational numbers, -2, 1, 5, but also anything that can be expressed as a fraction. 3/5, -4/7, 0.333 repeating. Any decimal that repeats, that's a rational number, because any decimal that repeats can be expressed as a fraction. What's 0.333?
1/3.
That's 1/3, okay? So any number that can be expressed as a fraction is a rational number. Well, it turns out you can express roots as rational exponents, okay? So for instance, say I were to do, so I'm going to grab my calculator here, and am I recording? Am I recording? I'm recording, right? I never know if I'm recording or not. Well, where'd it go? I'm recording. Okay. So say I were to take 36, and you have a calculator, you can do this on your calculator, and I raise it, you don't have to do it right now, to the 1/2 power. Watch, I don't know if this is going to work. 36, this might give me, if this gives me a big number, I have to change how I put that in. Nope, comes out to be 6. It's crazy. Crazy, okay? What's 25 raised to the 1/2 power? What do you predict?
I'm guessing 5.
5, okay? Okay? What's 27 raised to the 1/3 power?
3.
3, okay? So that kind of shows you something, and what that shows you is that, so those are equivalent to, whoops, I meant to get rid of this, not to get rid of that, okay? So where'd my writing go? Not there, there, there. So that tells you that 36 raised to the 1/2 power is the same as what? That's equal to the square root of 36, which is equal to 6, okay? And so on. 27 to the 1/3 power is the same as the cube root of 27, which you guys very wisely figured out is 2. Okay. Let me see. Am I getting ahead of myself? So the rule is a raised to the 1/n. Whoops, messed up. A raised to the 1/n power is equal to the nth root of a. Okay? And so we're going to try a couple things. Okay? So I would write this down on your notes. A to the 1/n is equal to the nth root of a. Okay? So let's try. You guys try on your whiteboards. Ready? 64 raised to the 1/2. Go ahead, write it down. 64 to the 1/2. Write it down. Piece of cake. You got it. You got it. Oh, that's good. Will, write it down. Calvin, write it down. What do you get, Calvin? You got it. That's right, Will.
Thank you, Mr. Leader.
You're right. You're right. You're right. You're right. You're right. But I want you to write it write out what the answer is. What is the answer? Okay? What is the answer? How about 64 raised to the 1/3 power? Go ahead. Try that. 64 raised to 1/3 power. You go, bro. Okay. Oh, sorry. Okay. Hello. Yay. Yay. Wait. Yay. Everyone understands why that's 4? 4 times 4 times 4 times 4 times 4 times 4. So this is equal to, that's equal to 4. That's equal to 8. We're good. Okay. Can do that, can do that. If they say, write an express, so we got this, we're done now. No, we're not. Sorry. I don't like that kind of paper, or the good kind of paper. There we go. So the other thing, if you have multiple variables, if they say write an equivalent expression, write. That's not how you spell right, is it? Hey, the fourth root of x, y, z. You can tell me, you don't have to do it on your whiteboards. That's correct. Except the x, y, z in has to be in parentheses. So it would be like this: x, y, z, all of that raised to the 1/4 power. Okay, so you do have to put that in parentheses because you're taking the fourth root of everything. Okay, simplifying square roots, that's pretty easy. I think you could do that stuff. But sometimes if the numerator is not, where are we going? I'm looking at these notes, trying to figure something out. What if I had something like this? Simplify 32 x to the 10th. That whole thing raised to the 1/5 power. Anyone know how to deal with that? That's a 32. That doesn't look like it. It looks like a 2 that's been turned into a 3. So if I did this, I'm going to give you an example and then I'll let you guys work on it. Okay? It would be 32 raised to the 1/5 power times x raised to the 10 times, remember the rules of exponents? You multiply that by 1/5. Remember that? Okay? So if you're raising a power to a power, you multiply the exponents. Who can tell me what 32 to the 1/5 is? That's 2, because that's the 5th root of 2. So 2 times 2 times 2 times 2 times 2 equals 32. How can I rewrite x to the 10th times 1/5? X squared. Very good, Ian. Okay? Do you guys see where Ian got x squared? Because this is equal to 10 over 5. When you multiply fractions, you just multiply the numerator and the denominators together. Since the denominator down here is 1, you have 10 over 5, which is equal to 2. So this simplifies to 2x squared. Okay? So we're going to have you guys try this one. This is kind of working backwards. Simplify 8 to the 2/3 power. In this case, you'll have to kind of go backward, okay? So you could, well, maybe I should, maybe you can do this. Try it. See what you could, it comes out to be a nice even number. Nope. Nope. Yep. Couple people got it right. What'd you get? Anyone know it? Yes? 4. Yep. Very good. 4. Did you get? So how is that? There's a couple different ways you can think about this. You can think about this as 8 to the 1/3 power raised to the 2 power. Or you can think about this as 8 to the 2 power raised to the 1/3 power, right? Because 1/3 times 2 makes, it doesn't matter which order you do it in, okay? What's 8 to the 1/3 power? That's the same as the cube root of 8, and then you're going to square it, right? Cube root of 8, and then you're going to square it. This is the same as 8 squared, 64, and then you're going to take the cube root of 64. What's the cube root of 8? 2, and what's 2 squared? 4. Okay? What's the cube root of 64? What times what gives you 64? So either way, you can either do it in either order. But if you see a fractional exponent they're asking to evaluate, sometimes it's easy to break it up into a fractional exponent, another exponent like that. Okay? Do I have another one like that you can try? Oh, here's the rule. You should write this down in your notes. There's the rule. A to the m over n, okay, is equal to the nth root of a to the m, which is equal to which is also equal to the nth root of a, that whole thing raised to the m power. So in this case, you take the nth root of a. No, in this case, you raise it to the power, and then you take the nth root of it. In this case, you take the nth root of it, and then you raise it to the power. Okay, so it's kind of like that. Okay, you guys are going to try one. Ready? Ready to try? You got it? You got this now? Then we're going to do a couple more things, and then we're going to have a little break. Oh, yay. Not so bad, right? Okay, I need a new sheet of paper. Where do I get a new sheet of paper? Here? No, that's not that. New sheet of paper over here. There we go. Okay, so you try 4 raised to the 3 over 2. 4 raised to the 3 over 2. You can think of this as the square root of 4, right? The square root of 4 raised to the 3rd power. Or you can think of it as 4 to the 3rd power, the square root of that. Both of them will give you the same answer. What's the square root of 4? No, square root of 4 is 2. 2 to the 3rd power is 8. 4 to the 3rd power is what? 4 times 4 times 4 equals 64. And the square root of 64 is 8. Okay, so either way you do it, it comes out to be the same answer. You want to try again? Okay, try again. Ready? So this one deals with a fraction, which Andres, we're using whiteboards. Yeah. 1 over. So here we go. Let me grab one. 1 over 27 raised to the 2/3 power. You're going to say, what? Let's go over this one. So you can think of this as 1 over 27, the cube root of 1 over 27 squared. That's the way I would think about it. Because you don't want to square it first, because that's going to give you some big, huge number that you have to take the cube root of, right? So you got to kind of think about it, right? Because if I squared it first, I'd have 1 squared is 1, but 27 squared is a big number, and then I'd have to take the cube root of this. So I could take the cube root of 27 and then square it. What is the cube root of 27? Because 1 over, so 1/3 times 1/3 times 1/3, right? Gives you 1 over 27. So the cube root of 1 over 27 is 1/3. And then I'm going to square that. And I would square a fraction. I get 1 squared over 3 squared, which is 1/9. Yeah? Dig? You get it? Okay. So now we're going to deal with ones that have, writing an equivalent expression. I think you could do that. But, well, let's try. Ooh, here's a tricky one. Another couple examples. And then we'll take like a 3-minute break. Okay? So, another couple examples. You don't have to, I'll give you a you try one after we do this one. So what if I had, write it, so sometimes I'll just have variable expressions, write an that's a Q. Equivalent expression to this. So if they say something like this, they mean write it with fractional exponents. So who could tell me this? I know you don't have to write this one on your whiteboard. How could I write an equivalent expression that? Go ahead, Adam.
It's 4x in parentheses.
Yep.
Raised to the 3/5.
Perfect. Okay. Raise to the 3/5 power, right? Because this says cube it. This is take the 5th root of it, so I could just rewrite it like that. Okay. So you're gonna try one. This one isn't too much more horrible. Try this one. 4x minus 1 to the 5th. To the 5th, like this. The 4th root. Go ahead, try that. Write an equivalent expression to that. So you know, this is going to be 4x minus 1 raised to the 4x minus 1, sorry, I was thinking ahead, raised to the 5 over 4 power, okay? Before I teach you the next thing, oh gosh, there's a ton more. How much more is there? Oh, not too much more. Yeah, you'll be able to. Before I teach you the next thing, sometimes you'll see stuff like this. They always boost it up a notch. A5, B, the 6th root of this raised to the 7th power. Okay? And you say, oh my goodness, what do I do with that? Okay? So this requires some steps. What you want to do first with this one is rewrite this as 2a to the 5th b raised to the 1/6 power, that raised to the 7 power. You understand what I just did? Okay? Because it's the whole thing, right? If it's the 6th root of the whole thing. So you put that whole thing in parentheses. Then what I want to do is multiply together these exponents. Okay? So I'm going to have 2a to the 5th b raised to the what power? 7 over 6. Okay? Then you have to raise everything inside of here to the 7/6 power. which is 2 to the 7 6. 2 to the 7 6. A to the how many 6? 5 times, no, you multiply. 5 times 7. 5 times 7 is 35 over 6. And B raised to the 7 6. So that's a pretty complex one. Okay? I think though, I think you could have just, I think this is the best one. Okay? If you left it like this, that'd be okay. Alright? Yeah? But this means this whole thing raised to the 1/6 power, that whole thing raised to 7. Need a 3-minute break?
Yes.
3-minute break. You have to stand up at least once. Okay, so you get some oxygen too. Okay, so coming back, if you remember the rules of negative exponents, it works the same way if those things are rational. Okay, so if you have a negative exponent up here, you can bring it downstairs and make it positive. So for example, if I have 16 raised to the negative 1/2, right? I can bring that downstairs and make it 16 to the 1 over 16 to the positive 1/2. What's 16 to the positive 1/2? What's 16 to the 1/2 power? Not 4, right? It's the square root of 16, so that's equal to 1 over. Okay? So if I have something like this, 64, I'm going to let you guys try this one. 64 to the negative 2/3 power. So first, if you did this, it's you can rewrite this as 1 over 64 to the 2/3 power. And you could do 64 to the 2/3 power by going 1 over, you can do the cube root of 64 squared, or you can do the square root of 60, oh no, or you can do, you wouldn't want to do 64 squared and then take the cube root. So the cube root of 64 is equal to 4, so it's 1 over 4 squared, which is equal to 1 over 60. Okay? So again, this is a case in which you could have squared 64 and then taken the cube root of it, but that would be a huge number, and I don't know if you know how to take the cube root of 64. Okay, I'm going to skip over a couple more things. I'm going to go to, oh, what if I have a fraction raised to a fraction? Okay, here's a rule that you should know. I'm going to just write down a good rule for you to know. If you have a over b raised to the negative n over m, like this, this is equal to, anyone know what I could do with that? Jessica?
Would it be B over A,
Raised to the positive n over it. Because this would be the same as 1 over AB raised to the nm, so you could just flip that fraction. Okay? So if you have something like, where's the example that I came up with? 16, so if I have 16 over 9 raised to the negative 1/2, that's the same as 9 over 16 raised to the positive 1/2, which is equal to what? What's the square root of 9? 3. What's the square root of 16? 4. Okay? So if you see something like this, just flip the fraction and make it positive, and then take the square root of that fraction. Okay. Oh, there's more. There's more. Do you guys remember rules of exponents? What's b to the 1/3? There's more. Yay! More. More. Yay. Okay. What if I had b to the 1/3 times b to the 5/3? And they say simplify. You have to remember your rules of the exponents. What do I do with those exponents? Multiply them or add them? Add them. Okay? So now you have to be kind of good with fractions. This is equal to b to the 1/3 plus the 5/3. What's 1/3 plus 5/3? 6/3. B to the 6/3, which is same as b squared. Okay? So they like to give you problems like this. We're not going to give you too many examples. What if I had, let's do one like this. Ooh, you're going to hate this one. We're not going to use, should we use whiteboards? Yeah, let's use, well, first I'll give you this. You try, okay? 7 to the 1/3 over 7 to the 4/3. What do I do with those exponents? What do I do with those exponents? Subtract, okay? So you guys see if you can rewrite that. For that one, you subtract the exponents. 1/3 minus 4/3 is equal to 7 to the negative 3/3, right? 1/3 minus 4/3 is negative 3/3. 3/3 is the same as 1, right? So 7 to the negative 1, which I can rewrite as 1 over 7 to the positive 1. I think you should try another. Ooh, that's ugly. How about this? What if I had something like this? 11 to the 2/9 raised to the 3rd power. What do I do with those exponents? Multiply. So that one is just 11 to the 6/9, which is equal to 11 to the 2/3. Is your brain full yet?
Yes.
Okay, so we're going to do a couple more. Well, they get even worse. Sorry there's so many, but, all right. What if I have something like this? M, you're going to look at me and say, what? M to the 2/3, n to the negative 1/4. That whole thing raised to the 1/2. Would you guys know how to deal with something like that? What do I do with these exponents, Chase? What do I do with this exponent? What do I do with the 2/3 and the 1/2? Huh? What? Okay. Can you make a guess? What do I do, Kaylee? I multiply the exponent. So I multiply, this is 2/3 times 1/2. What's 2/3 times 1/2? 1 times 2. What's 1 times 2? What's 2 times 3? 6. Okay? What's 1 times 1? Whoops. What's 1 times 1? I bet you know what 1 times 1 is.
18.
Negative 1. What's 2 times 4? 8. If I wanted to completely simplify this, what does 2/6 reduce to? 1/3. How can I make this one positive? How can I make this one positive? Yeah, bring the n downstairs. Make it 1/8. Okay, so that's how you would simplify something like that. And then I think you guys are zoning out, so I'm not going to do too much more. But if you see something like this, which you will on your homework, you're going to go, what the heck does this mean? And then we're going to do some Kahootas, okay? What if I see something that looks like that? A root inside a root.
Wow. Retention. When you take that.
You just multiply the roots together. So this is equivalent to saying xy raised to the 1/4. That whole thing raised to the what? 1/3. And then you just multiply those two exponents together. So that's equal to xy raised to the what? 1/12, like that. So if you see a root inside a root like that, you can simplify it like that. Another way you could write that, that's equivalent to the 12th root of xy, right? This is equivalent to saying this, yeah? And I'm just looking to see if there's anything else I'm missing. I don't think that, I think that's good enough for now. Okay? So, we're going to stop here, and we're going to Kahoot it for a while. The Kahoot its are easier. Okay?